In this video, I'm providing an additional example of substitution in order to solve for a system of equations. So just if you're following along from the previous video, this is using with fractions instead, to kind of maybe alleviate some stress when you see fractions. So similar to the previous video, y is equal to this, and I'm going to substitute it in for the y that's in this one right here. So we always start out with y equals some equation, and then I'm also given an equation that's not written in slope-intercept form. So this is when we would want to use substitution. So from there, I'm going to write 2 times 5/4 x minus 1 plus x equals 12. Again, I'm going to follow the order of operations, which means that I am going to distribute this 2 into the parentheses. So when I distribute, I get 2 times 5/4x minus 2 plus x equals 12. So at this point, of course, it really depends how comfortable you are. I'm going to show an additional step or some additional work just so you know exactly what I'm talking about. But if you don't need to do a couple of these steps, it's totally okay. Don't worry about it. The biggest thing I want to stress right now is do not write this as a decimal. So leave this as a fraction. It is super important you do that. Do not rewrite this as decimals, okay? So if you want, if you're more comfortable with it, you can put this over 1, and then you can do this part by multiplying across. So then you would get 10/4x minus 2 plus x equals 12. And then you can simplify, and this simplifies to 5/2x minus 2 plus x equals 12. If you are able to do this in your head, that's totally fine. You can skip putting it over 1, and you can also skip going from this to this if you're able to do so. This is just showing the additional step in case you do need it. So notice right now that I would love to combine my like terms. So I have this 5/2 and this x right here, but it makes it difficult because this is not in fraction form. So what I am going to do, instead of keeping it as x, I'm going to write this as 2/2x just to make it easier for myself. So again, some of you might be able to do this mentally. That's totally fine. You don't need to write this step per se, but if you do need to write it, please do. It makes it a lot easier in terms of making sure you don't make any mistakes. So remember, 2/2 is the same thing as if I had a 1 in front of this x, this is a single 1x. So this just allows me to add my fractions together more easily. So I'm going to add my 5/2x and my 2/2x, and I get 7/2x. Then I'm left with minus 2 equals 12. From there, I'm going to add 2 to both sides so I can get my x by itself, which means that I have 7/2x is equal to 14. So this is the point where a lot of people end up struggling when we're solving equations. It's like, what do I do with that fraction? Because that fraction is being multiplied right now to x. So the answer is that I want to multiply by the reciprocal. So what does that mean? It means that I'm going to take this fraction here and I'm going to flip those values, and I'm going to multiply it on both sides by that. Because remember, if I multiply by the reciprocal, it makes it so it becomes 1. So if I multiply instead of by 2/7 on both sides, and if you want to put 14/1, that's totally fine. If you don't, that's also totally fine. It means that now I have over here, this becomes 14/14x. is equal to 14 over 1 times 2 over 7. Notice that 14 over 14 becomes 1. So this is just x. Over here, again, if you want, you can multiply across so that we get 14 times 2, which is 28. And that would be over 1 times 7, which is 7. And then I can simplify and say that x is 4. The other option, again, is for some of you, you might be able to simplify just by looking at it. So you might be able to easily go from here to here and skip this step too. That's also okay. So long as we can all see your work, we're totally fine with it. So we are left with x equals 4. The next thing I need to do now is determine what y is. So I'm going to plug in x equals 4, and I'm going to decide what equation I want to use. I can use this top one, and I can notice that if I use this top one, I would get this times 4, and then the numerator and the denominator of 4 would go away and become 1. Or I can use this one, which in this case, I kind of want to use this one, I think. So just to show something different, we end up with 2y plus 4 equals 12. So now I need to solve for y. So I'm going to subtract 4 from both sides, and I get 2y is equal to 8. And then from there, I'm just going to divide by 2 on both sides, and we get y equals 4. So that means my final answer should be 4, 4, where they intersect.